everyone. And so I am so excited to welcome our colloquium speaker for today, who is Xanda Schofield.
Schofield?
Schofield, sorry, I did not just ask how to pronounce her name. She's an assistant professor at Harvey College in computer science. So she did her PhD, completed her PhD in 2019 at Cornell, working with David Mimno, which makes her my academic niece, even though academically we are the same age, so like weird family dynamics. Which, yeah, I can say they're weird because like that's, I was 7 when I had my first niece in real life. Yeah, and during her graduate career, she's a recipient of an NESEC fellowship, an Anita Borg Memorial Scholarship, and a Microsoft Graduate Women's Scholarship. So she works on practical applications of unsupervised models of text, particularly topic models applied to research in the humanities and social sciences. And I think she's going to talk a bit about that today. And more recently, her work has expanded to the intersection of privacy and text mining. I'm super excited for her talk, so please welcome Xanda.
Thanks, folks, and thanks, Emma, for the introduction. Hi, all. I will say, of course, for the last name thing, I go by Prof. Xanda at the school that I teach at, in part because it's just a huge issue. My name is spelled wrong for the pronunciation it has. It's no one's fault but mine, really. I'm delighted to talk to you all today, and I think it might be a little bit of a different talk than sort of the classic research talk. And with that in mind, I just want to invite you all. I'm happy to be interrupted so that we can talk about the things you're all interested in talking about. So if you see a topic in your hair and then I start moving on to something else and you're like, no, wait, I want to ask more about that now, feel free to raise your hand, interrupt. I'm all about that. It's great with me. Awesome. And then also, I think if you're on Zoom, you can raise your hand as well. I might not notice immediately. So is somebody looking out for that?
I can.
Okay, fabulous. Thank you, Jonathan. Okay, so today I'm going to talk to you about why computational text analysis, which is sort of a broad area of work that I help with, isn't always a piece of cake for people to do. And just to start, I think it would be useful for me to give information about who I am. So I work at Harvey College. I'm in now my 4th year of being an assistant professor, but if you do the math, that means that I started in 2019, so no 2 years have been the same since 2019, so I feel like I'm a first-year professor. Harvey College is a little tiny school in Southern California. The total size of our student body is 900 students. They're all undergraduates. And so I spend a lot of my time focused on undergraduate teaching as a part of my job. I actually went to Harvey as an undergraduate student myself, so I'm sort of in the weird, delightful situation where I teach at the same school that I took some classes at, and therefore work with my colleagues who care a lot about teaching, but who also have seen some of my worst moments of learning computer science. So it's just exciting and different. But it's a really cool place in terms of being able to sort of embrace breadth. We have primarily engineering and computer science and math and STEM students, but there's a broad emphasis on sort of including humanities, social science, and the arts in their educational trajectories as they pursue those majors. And so it's a very interdisciplinary, friendly place to work for me. Just because I think some of you all may not be that exposed to what it looks like. So I should say I'm an assistant professor like on the tenure track. And I think some people don't realize that at teaching schools there are tenure track professors. And I just wanted to briefly mention like what that looks like in case for some of you all who are currently graduate students, that's a job you might consider in the future. So at a research-focused university, usually if you're a professor, you're teaching like 0 to 1 courses a semester. And that's my understanding anyways. A lot of standard research universities. You might be able to buy yourself out of some teaching if you get enough grant funding. You're primarily focused on raising funds and supervising and managing the research of graduate students. You might also have some undergraduate students, but that's sort of a bonus thing that you would do. You participate as part of your job in like governance of the school and committees. You do a bunch of other stuff. You perform scholarly service. You're reviewing for papers. You're a chair of different things. So this is the stuff that fills your time. And ultimately, the way that you're evaluated for tenure is primarily focused on doing outstanding scholarship and then being at least satisfactory in your teaching and service to go along with that. Did I get that roughly right? Is that sort of the rough picture of what it's like? Okay. So at a primarily undergraduate institution, it looks a little different for a few reasons. First off, and I didn't actually highlight this as a change, I teach about 2 classes a semester. The reason I don't highlight that as a change on its own is when I say I teach 2 classes, right now I'm teaching 2 sections of algorithms, like the write proofs about NP hardness and learn how dynamic programming works class. And when I'm teaching that class, I'm teaching 2 sections of 30. In contrast, I was a lecturer briefly while I was still a PhD student at Cornell, and that was one class of algorithms that I was co-teaching with 300 people in it. It's a very different kind of teaching to do 2 sections of the same class with 30 students that you can get to know over the course of the semester. So it looks a little different, and describing the teaching load just based on the number of classes per semester doesn't fully reflect that, but there's also expectations around what my teaching looks like that have changed. When I'm doing my research, I am supervising and raising funds for only undergraduate students. I have no PhD students. Pretty much no one has postdocs. Very occasionally there is a postdoc at Harvey. I'll mention one in a little bit. And that means that I'm spending a lot of time teaching people how to do research on their very first research project they've ever done. That's pretty much all I end up doing, is working with people who haven't done research before, or haven't done research at least in CS before. Which is really fun, and also very different from working with graduate students. It's a kind of exciting thing to do. It primarily only fits in the summer, since they don't really have time to do more than sort of like ramp up on what a research project is during the school year. So it's a little different. Like everyone else, I have to do departmental governance, I have to review papers, I do all the things that professors do. And then my tenure criteria are on the basis of outstanding teaching and satisfactory research. There's a little bit of a flip. So for me, what they want me to do is, in order to be an effective instructor for the students, they want me to stay engaged in the research community, but the priority is not on me getting lots of papers out or getting enough grant funding to do something really big and exciting. It's on keeping active enough that I will be good at teaching students. Which means that when I'm describing the research path that I'm on right now, the timeline is going to look a lot slower. And I just want to be explicit about that, because I think it's something that's worth disclaiming about this kind of job. I still do research, I still can get tenure, and it means the same thing as it would mean here, but my research agenda, the way that I carry it out, who I carry it out with, and what my incentives are for where I publish and who I talk to are very different than it would necessarily be at a larger research institution. And if you have more questions about that, I'm happy to talk to you either individually or at the end in a Q&A more about what that looks like. Sound good? So that's the context I'm in. I'm talking about a research agenda that lives at this sort of strange little wonderful place where my priorities are mainly teaching, where doing work that isn't as recognized or doesn't get as much money is okay, where I can get away with things like primarily publishing in venues that aren't actually computer science, which I'm working on right now. And sort of just like explore stuff with people who are seeing this for the first time, these awesome undergraduate students that I work with. Well, so my specific research focus is how to help domain experts use computational text analysis to answer questions about large text collections. And let me just break that down. So first off, when I'm talking about computational text analysis, I'm talking about broadly tools that people can use when they have a big collection of text that's too much for them to read, but they know stuff about what's in it, and they want to answer questions about what's in it, and they want to use algorithms to do, right? So that includes some like very fancy NLP things. It also includes a lot of very basic NLP things, and sometimes even just counting stuff, like really statistics. And when I'm talking about domain experts, what I'm really talking about are people who are experts in the field of the text, as opposed to in the field of computational text analysis. So an example for 2 of the people that I'm working with right now are Professors Manisha Goel and Michelle Zemmel. I should have put professor in front of these people's names as well. They're both economics professors at a college right next to mine, like literally 5 blocks south of mine, Pomona College. And we talk together about text analysis projects. I've also worked with sociologists. I'm currently working with an atmospheric chemist. And I've more broadly, even though I don't necessarily publish papers with them, meet with people who are from lots of different humanities and social science fields. We'll grab coffee and we'll talk about how do we actually get text analysis algorithms working. It's one of the most fun parts of my job. I get to visit different random projects with interests that aren't actually the thing that I got to study in school, my very narrow specialization. And I get to learn all about their stuff and then be like, cool, let's talk about word endings. It's a good time. Now let's think about what these projects look like. I'm going to talk about an example project right here. By the way, my apologies for the super janky animations. I forgot to turn them off just before this. Did not mean to enable them. So we should all laugh together as janky animations occur. That was really gross. Okay. So one of the particular projects I've worked with Manisha Goel on, along with some other folks, is specifically interested in understanding how required skills in the job market are changing across different jobs and industries. So Manisha actually started this project before I even joined Harvey Modded, before I had met her. And when she started this project, she had worked with this company, Burning Glass Technologies. And Burning Glass Technologies has a database of 50 million plus job postings. huge database of different things from 40,000 different sources where job postings are put. And she was like, this seems like a really rich place to understand how the skills and needs of the modern job market are changing. And lots of people have written papers about broadly where they think this is going, but maybe we can actually just data mine and find this. And maybe we can find this not just from lists of skills that are in bullet points, but from the natural language text that's in these job postings. What are they prioritizing? Now, of course, this is a huge question. How are required skills changing across different jobs and industries? If I was talking to my undergraduates and they framed this as the topic of their project, I would say there's a scoping issue here. We should work on the scoping. Maybe some of you all have trouble with scope as well. I know I do. So the starting point was narrowing this down a little bit. And specifically, Manisha became more interested in automation and how the implementation of AI and machine learning technologies has affected what job skills are required, not just if you're somebody graduating with a degree in computer science and you're interested in going out into the world, but also if you're somebody who doesn't have a degree in computer science, but you're working in a field that's now automating things a bit more. Like, what are they expecting you to be able to do to interact with those technologies? So Manisha had narrowed down this question to like jobs related to artificial intelligence and machine learning in some capacity. Not necessarily people who are directly implementing these models, but people who are in some way interacting with them. What do they need to do, and has that changed from the days when these automation tools were first starting to appear versus now where a lot of them are a little better established? To help with this project, prior to finding me, Manisha had already recruited 2 people. One was Chris Nardi. Chris Nardi just graduated from Pomona, wonderful student. And the other was Atya Shkliar, who worked at Pomona in IT, but happened to have some information about like how to do data processing. They'd all found each other and they were like, maybe we can figure out some progress on this cool data set. And they had spent about a year working on this following recipe. And I think this is a very classic recipe that we develop when we have a large text collection and we're like, I want to learn more about what's going on in here. It's like we first find the collection, we process the text in some way to get it ready for an algorithm to be able to handle it. We learn a model on it, and then we interpret that model to see if we found out something interesting. My guess is if you all are at LTI or interested in LTI, many of you have gone through some version of this recipe before, right? This is a fairly familiar, very broad strokes recipe. And when I think about recipes, I think about the Great British Baking Show. How many people watch the Great British Bake Off? Anyone? Handful of people? We all admit this, it's very exciting. If you haven't watched it, you should watch at least a couple of episodes. It's the most wholesome competition show ever. One of the things that happens in the Great British Baking Show is this thing called a technical challenge. And I know we all face technical challenges in our work every single day, but a technical challenge in the Great British Baking Show works like this. Everybody starts out and they've got like a blanket on top of, or like a tablecloth on top of a pile of ingredients and a flipped over recipe. And they're given a certain time limit and they're told, you're going to make a thing, like a princess tarta. It's a special kind of cake. They're given no picture of what this thing is, they're told what the thing is, and then they're given a really basic recipe. And they're told, go make this, you have 2.5 hours. Go. They get to open up the ingredients, go look around, and try to implement this thing. And my feeling is that honestly, when we're thinking about these recipes, we don't get all of this structure. So this one right here says like preheat the oven, and then it says make the jam, the vanilla custard, the marzipan, and the sponge cake. And if you're super into baking, when you see this ingredient, maybe you're like, oh yeah, I know exactly how to do that. I will say I'm relatively into baking. I do not actually know how to do all of those things without a recipe off the top of my head. It's a kind of overwhelming thing to do, right? Do any of you know how to do this off the, if you do, then I'm very excited to talk to you more later. Okay, no. So in some ways, I think this recipe, this version right here, is a lot like this recipe. Like, this is a thing that people will regularly come across as they're outside of NLP, but aware that they could use natural language technologies to analyze their question. They get this sort of story of what they need to do. And they're like, okay, cool, I will try to do that. And then they hit the second step, process the text, make the marzipan. And they're like, what? How? And so they start looking up other ways that people have done this. And sometimes it matches what they're trying to do, and sometimes it doesn't. And there's a lot of trial and error, and it's kind of a mess, because honestly, and this is a screenshot that Netflix tried to prevent me from taking. I've never heard of it, I've never seen it, is the text on here if you can't read that very well. As you're doing these sorts of things, the issue is you don't necessarily know what a good final product looks like, especially when you're applying a model. If you haven't been using these kinds of models before, it's difficult to discern If you get a model that doesn't make sense to you, whether that's a problem with the model you're using, a problem with your data set, a problem with your assumptions, a problem with your research question, like, you kind of don't know where to look. You're just like, I don't know what this is supposed to do. Maybe this is what it looks like when it's running correctly. Maybe we'll try that. So in this project, when I joined, it was about a year in, and they'd been engaging in this process. And they were just hitting their head on how the heck do we actually get this text process in a way where we could learn answers to questions about job ads. So really one of the things I'm interested in, wow, that was ugly. That was a great animation. What I'm really interested in is what types of operations, what are the parts of these tasks that really make it so it's not a piece of cake to build this recipe of how we process our texts. And that's something that I've been looking into more in the past couple of years, not just in terms of like, oh yeah, there's individual diagnosable pieces, but broadly, what does that process even look like? Now, almost all of my work has been focused on topic models. How many people have worked with topic models? A handful. Okay, actually a decent handful, which is good.
A bunch of us
All of that, okay.
All of them. So the reason why it's a bunch of the faculty and not the students is because back in the day, this was the hip thing. There was this whole period where people were like, how? Like probabilistic models showed up and people were very excited. And actually, I can go ahead and walk through the timeline in a moment. And then neural nets happened. And somehow topic models just don't come up as much in conversation anymore. So don't fret if you haven't seen them before. We're going to just talk about them at a high level briefly. Happy to answer more questions as we go. So briefly, when we're training topic models, what we're really trying to do is it's an unstructured, unsupervised model. I shouldn't say totally unstructured. It works on typically unstructured text. And so what we're starting with is raw data. We're going to compute some sorts of collection statistics about our raw data. And then we're going to turn that into summary information. Again, this picture is super duper general, right? This applies to like 90% of what people do in machine learning, broadly speaking. We take data, we make features, we make models. When we're talking about topics in topic models, we're naturally drawn to thinking about human topics. And humans, when they're interested in topics, they're talking about concepts that exist in the world that engage with certain pieces of information more than others. So if I'm thinking about jobs, I might be interested in jobs that are related to database software. Now, that isn't just a category of job. There are jobs that are not database technician, but that relate to database software. And likewise, there are jobs that are technically heavily associated with databases, but when you read the description, you discover that actually they've just got a bunch of text files and they're not querying any databases at all. Right? So we have topics that are these concepts that are grounded in real-world context. And then we want a computer to help us out with those. Now, when computers represent topics, we actually go for something that's a lot more simple because our model of the world is going to be trying to gather some collection statistics. We've got some data set and we're going to get statistics out of it. We don't have access to the real world. We just have access to this text. So in this particular structure, and I know some of you all work on information extraction and reasoning about common sense, and so this is the very lazy approach to this. We're going to have our computational topics literally just be probability distributions over words or types in our data set. So I can have a topic that has a high probability of the words recognition and language and NLP and speech. And when I say high probability, realize that 1% of like 10,000 words is actually a very high proportion in vocabulary, right? I'm going to have a probability in each of my topics of every single word in the vocabulary of my text for however I establish that. And using these particular probabilities, my hope is that I can go ahead and look at those top probability words and as a human say, this looks like this is about language processing. And then I can say if a document has a lot of this topic, if I can find some way to represent documents in terms of proportions of topics, and I know that those topics have proportions of these words, and I think that a bunch of these words together sound like they're about language processing, then I can say, hey, the documents that have a high proportion of this topic are probably about language processing. And that helps me start to grapple with a very large text collection that I couldn't necessarily read. A standard probabilistic topic model's output looks something like this. And if this looks like a matrix decomposition, that's not an accident. At some level, it fundamentally is, even though it's not inferred in a sort of standard matrix decomposition way. Over here, on this left side, we end up with a matrix that is skinny. This is the number of topics we're interested in inferring, which might be a number we specify in our model. And then we've got a vector for every single one of our documents, and that vector is the probability over each of the topics. So I can have, within that, a document that has like 50% topic 1, 20% topic 2, 0.0001% topic 3, and so on. And then over here, I've got the proportions of the words in my topics. So here, this is my vocabulary size, which might be very, very large. And every single one of these rows is going to be a single topic. And for every single word, I'll have some probability. My hope, if I'm being reasonable about how text works, is that most of the probabilities in a given row are going to be very small, and a few are going to be a little bit larger. Because when we think about things coherently showing up together, we hope that we're not getting the entire dictionary in a single topic. That doesn't feel like coherent to us in terms of a particular theme. So if I have a topic like topic number 5, and it's all of these recognition, language, NLP, speech words, and I have some document over here, maybe posting 12,561, and it's 80% topic 5 and 10% topic 2, then I can be like, I think that this job posting might be talking about language technology, right? Which is cool. So when we're actually inferring a model, what we're trying to do is we're trying to say, given a corpus that we've now rendered in this sort of statistical way, and a number of topics, so we've picked what this size is right here, like what the sort of width of that matrix and the height of this matrix is. What is the best set of topics that are sort of filling in these probabilities to summarize the words that are showing up in the documents? Ideally, so that if you multiplied these two matrices together, you'd get something like the proportions of each word in each document, right? Does that sort of make sense? High level? It's not a particularly fancy model of text, is it? Like, we're just counting words. It's a bag of words model. We're not really getting into the details here. And even then, we're still going to have to approximate a little bit because we can't actually algebraically solve for the best set of topics. That's a huge, ridiculous computational space. So since that's intractable, we're going to do something iterative to try to learn that, like variational inference or MCMC, Gibbs sampling stuff. So we will try to converge on a very good set of topics. Now, these models have existed for a long time. Like initially, we started out with latent semantic analysis, which didn't have probabilities necessarily built in, although there was a model that came shortly afterwards, probabilistic latent semantic analysis, that followed up on this. But this is like 1990. We have something that basically looks like this model. LDA itself, which is sort of the classic probabilistic topic model, showed up in, it says 2003, but really the first work on this was in 2001. And then from there, people got really excited about using topic models. We were talking about this chronology earlier. This was around the time where probabilistic models were getting really big in NLP, and people were like, how could you do that instead of rule-based models? The world is falling apart, which ended up being a familiar story later on. So this probabilistic model thing grew, and people came up with special purpose versions of LDA, things that could handle like, if you don't want to pick what number of topics you have, it'll infer it. That could handle hierarchy, that could handle representing time, that could handle representing different authors. They were like making all of these different fancy versions of these models. Eventually, people were like, these models are kind of slow to run and a little bit weird and have some properties we don't like. Maybe we can try making things that use other kinds of matrix factorization instead, and that are a little bit more predictable, run a little bit faster, do some other things that we like, and even allow us to input some additional supervision. And so there's things like anchor-based topic models. There's a few different works that use spectral strategies, so finding eigenvalues and eigenvectors in order to help find topics, which seems natural, right? We're decomposing something into sort of the salient elements that make up what the text is. That feels very eigeny, right? Am I allowed to use eigeny as a word? I might be doing a lot of coinage right now. So there's different strategies that people would use to sort of build up these models. And then sort of more recently, like starting in 2016, people have also used neural networks for it because, surprise, surprise, the same thing happened again in the field. Neural networks came along and people were like, you're not going to need a new process. We've got all this probabilistic stuff that's working great. And then neural nets did really, really, really well. And now we use neural nets for almost everything, right? So people created neural versions of these models too. Things that we're trying to find these topics that go together, and we're inferring them, and we're finding metrics that they could use. There's a 2016 paper that sort of introduces one of the first ones. It's based on variational autoencoders and sort of classic LSTM stuff. And then there's a few more papers that followed on in 2017, 2018, 2019 that are sort of the most recognized versions of these models. I think there's even one. Most of this stuff wasn't BERT-oriented. It was sort of pre-transformers. But I think in 2020, somebody even put out a paper, I think it's Alexander Hoyle, that was talking about using a sort of like an existing transformer net and then applying knowledge distillation on top of that to get topics that way too. So lots of different ways that we're basically trying to build this same structure. And we've iterated over different algorithms for how we can do that over time in the NLP community, published lots of papers. There are so many models out there if you look up different topic models. And the reason that we would say that there's these many models is theoretically because first off, it's a simple representation of text. You put your text in, you're not making a lot of assumptions about the structure within the text, just that there are countable things, right? These words that are showing up together. And then from that, you get these probabilities out that you can use to directly make decisions about documents, about the individual words that are showing up in the documents. It's like very nice and easy to interpret, even if you're not a computer scientist. You can train one of these models, get it running, and be like, hey, this is a theme that shows up in my text, and here's where it shows up. That's a cool, powerful thing to have for lots of different types of applications. It's adaptable to different situations. You can even adapt it to things like a music playlist. Your words are now songs. Your playlists are now documents. Maybe you can find out which genres show up. Or one example that I particularly like is archaeological artifacts. You can use rooms or spaces that these artifacts are found in, and then the actual types of the artifacts that you found, and try to figure out whether there was a different sort of cultural situation in daily life for how people were grouping things together. Like, do they have just a standard kitchen separate from a dining room, or are those two things together, right? So you can do some pretty amazing, very different things using this system. And there was a bunch of software that got built to make it so you could kind of just run this on whatever your new text collection was. Or that was the idea. Anyways, it turns out that things ended up getting more complicated because of this gross thing that I suspect pretty much all of you have encountered before, which is preprocessing. How many of you all have spent some time worrying about preprocessing a particular text collection? Yeah. It kind of goes with the territory, right? If you're going to work on language in any format, like natural language, at some point you have to worry about processing text. So this definition is probably not particularly interesting for you, but I do want to sort of establish it because sometimes this actually can be a little controversial. So I describe preprocessing as the practice of modifying the format and structure of data to make it possible for a computer program or model to use that data effectively. Is that a definition we're OK with? Because the thing that I will highlight here is that when we talk about preprocessing, we often think of it as sort of this neutral thing that we have to do before the actual process, right? It's like, get this done, and then we can start doing the serious modeling and decision making. But when we do preprocessing, we make decisions about what we keep and how we keep it. In fact, a quote from my colleagues Laurie Thompson and David Mimno is that preprocessing is purposeful data modification. We have to make choices, and ideally justified choices, about what we're keeping and what we're losing in our text or in whatever our data source is in order to be able to make it processable by an algorithm. Because texts in their natural form are not that tidy. There are lots of different preprocessing steps that end up having an effect on models like topic models. I've written some papers about some of these, things like removing stop words, things like conflating words by their roots, so this is like your stemmers and your lemmatizers, text deduplication. I don't know if any of you have had an experience where you've worked in a collection and you've discovered that your news collection that was highly curated has 10 copies of the same news story, or your collection of data ends up continuing to reuse the same examples. Even handling more recently multi-word phrases. I did an awesome project with Tay right here, as well as Jin, who I don't have a picture of sadly, who are both at Chulalongkorn. And we were interested in like how much of a difference does it make if we can capture like project management as a phrase in our jobs versus just product and management separately. And all of these things are things we've been doing in NLP for forever, right? This is not like recent statistical machine learning stuff. This is the 1980s. This is the 1960s in some cases. We've been worrying about how to process text in a way that makes it intelligible for a very long time in our field. And yet we're still having problems in terms of figuring out how much these decisions affect our text or when we should be making these decisions. For instance, in our stop word removal paper, we were discovering, as we talked to people using topic models, that they were spending an awful lot of time figuring out exactly which words they should remove before training their model. We're like, we should definitely remove like the and so on, but I'm working on job postings, so like, should I get rid of the word job? Should I keep that or not? And what we found when we ran analysis, when we were trying to compare this, is actually after you get rid of the words that are really, really common, it doesn't make that much difference to the model whether you get rid of those words or not. The reason that people thought it was a big deal was because it makes a difference in the way that the model looked when they were reading through the topics. Which makes me feel like we should talk a little bit about what actually makes a good topic model, right? This is an unsupervised model that I just introduced you all to, right? We didn't have any labels. We were like, what topics show up that make things good? So how do we evaluate whether a topic model is good? Like, should it have distinctive topics? Like, should it be easy for us to tell our topics apart from each other? Should it recapture categories that we already know about in our text? Should it be easy to label those topics? Should it contain only interesting content? These are all questions that we might actually have as we start to use topic models more, like when we're trying to diagnose, like we're in Manisha's situation of like, are these topics actually good? And there are usually 3 things that we actually use when we're developing metrics to evaluate topic models. And there are variants on these, some that combine, some that take a particular aspect, but there's 3 common aspects that people care about. I don't know why that animated quite that way. There we go, okay. And those are likelihood, coherence, and diversity. Likelihood is a classic statistical thing to care about, right? We have a model that explains probabilities of words showing up in topics, probabilities of topics showing up in documents. That generative story together gives us an ability to estimate probabilities of new unseen documents showing up, right? We can't directly infer an exact value, but we can approximately assess whether, given this model of the proportions of words and topics and so on in the text we have seen, whether that generalizes to text from the same source that we haven't seen. And if we think that it does that well, then maybe it's a good topic, or a good topic model. It generalizes well to the new data we see, right? Which is a lovely idea. It seems like a classic way to evaluate statistical models, and it has been. Unfortunately, there was a paper that came out in 2009 that says that this really doesn't fully correlate with what people actually see as good models. There's a beautiful paper called Reading Tea Leaves, How Humans Interpret Topic Models. And this paper breaks apart the fact that when people were actually looking at models, models with high likelihoods weren't necessarily interpretable. And the things that people really wanted were like not only to have topics that explained the text that they had, but topics where the top words, the high probability words, which are often what we use to visualize our topics, will be like, what are the top 10 most probable words in my topic? But they wanted those to go together. And if they couldn't see how those words went together, then it was hard for them to make sense of what this topic meant in context. They couldn't do the thing where they looked through like the list of words we did and say, hey, this is probably about language technologies. So they also wanted to have something about coherence, whether these high probability words actually make sense together. And at first they did this with this human task where they'd have people try to identify whether there was a word that didn't belong with the others based upon sampling words from the same topic versus a different topic. And then eventually they were like, oh, we can automate this metric. We'll figure out how to automate this metric, and once we automate it by sort of estimating using like a local word window, sliding over all of Wikipedia, how often these words show up together in a reference corpus, we can use that to identify whether these words are showing up together sort of in a reasonable fashion. So they tried to automate this idea of coherence as a metric. It turns out more recently, a paper has come out, I think it's a 2021 paper, that says that in our process of creating an automatic metric for this, we've sort of lost the point. That sometimes this coherence metric is failing to capture that when words show up together, that doesn't necessarily mean they're meaningful words for us. I can get an extremely coherent topic by getting a bunch of extremely technical terms that only show up together as my highest probability words, and not representing something that's general enough to actually cover lots of different documents to help me find a theme going across an entire corpus, which is kind of awkward. So we can have topic models that are highly coherent but are not necessarily helpful for us answering a question. And finally, we might be interested in diversity. Like we want our topics to actually cover different things. And this too, we can try to propose automatic metrics for, and there are some, including one that's just called diversity. And we still run into an issue where we can have topics that are very different, but we don't know if they entirely cover the space that we're interested in. They might be tiny little probability, like very focused probability distributions that cover altogether a quarter of what we're really interested in our text collection. So what we've come to is a situation where we really have to report on a lot of different kinds of things to be able to say whether a topic model in the sense of how we evaluate models in the NLP community is good, right? And awkwardly, none of these things is really taking into account if you're a text analyst who's got your own corpus and your own research questions, which pieces you actually care about. These are all things that are broadly talking about with respect to the corpus, is this model expressing this? Are these words going with respect to this other reference corpus? And if I'm really interested in jobs in AI and what's culturally changing over time, and I know a bunch of history about that, I don't know what the heck any of these metrics are telling me, besides probably that bigger is better, since that's how I usually interpret a table of numbers, right? Like, oh yeah, those numbers went up. That one's even bolded. Great, love it, right? But using these metrics on their own wasn't necessarily helping to find good models. It actually turns out that, this is just an aside, so I wrote all of these different papers that were about how to evaluate these pre-processing techniques. And it turns out even reasoning about whether pre-processing techniques work or not is kind of a pain, because all of our evaluation metrics are built on what we in the sort of machine learning or natural language processing community do, which is develop a new model and see if it's doing as well at representing our data as our existing models, right? Classic thing to do. We've got different metrics. Maybe it's an applied task. Maybe if we're doing an unsupervised model, we have intrinsic things like these. We could create like task-oriented things that are whether or not our topics can label particular categories. It can separate our news groups from 20 news groups. Sometimes people do that, and sometimes that's not actually what they're interested in discovering. But when that's your strategy of evaluation, where you've got different models, and the thing that you're controlling is the text that's going into them, how do you evaluate pre-processing? Because fundamentally, a lot of my work, we're changing the data between the models. And the metrics that are designed to compare between exactly the same data but with different models don't work when the size of the vocabulary has just changed. Or when we're thinking about the same vocabulary, but we're thinking about how to group words together into multi-word phrases. It actually fundamentally messes with the axes on which we're measuring things. If you have a larger vocabulary, your probability distribution is spread across more things. Things become less probable. What does that mean for evaluation? Is it bad that the probability dropped because we included more words in our vocabulary? Maybe, maybe not. Depends on what we're interested in learning. So it's been a whole tricky thing to sort of navigate how to even answer questions about this. But through doing this work for a while, writing a bunch of papers where I got a lot of reviews back saying, it seems like the experiments are good, but maybe write about something a little bit more interesting than pre-processing next time. Which for real, it's a fun review to get. But nevertheless, so I've done a bunch of work on this, and we've increasingly discovered that there's lots of pre-processing things where there's multiple options that work just fine. The question is really what you're interested in finding out from the data. So I show up, having done a bunch of work on this in my PhD, and I join Harvey Mudd College. I give a talk about topic models at the library at one point, and Asya finds me and is like, you have to come talk to this economics professor. We're trying to do a topic modeling thing, and it's a hot mess. And we talked, and as we were working through things, one of the things we discovered, like they've tried to train topic models, and they seemed to look kind of useless. They were either getting a list of company names, or they were just seeming like super duper vague. Things like, oh yeah, job, want, expectation, community, about, like the sort of words you would expect to see in a job posting, but not specific enough to really learn about what's going on in the job posting. That's not ideal. So, Asya mentions, I saw this random professor give a talk about topic models. We should ask her why they look bad. And I was super excited. And I was excited because I was like, oh, look, a real data set. Like I was just doing stuff on like, I think I had just done a thing that was related to Enron text data. And I was like super over the Enron email data set at that particular point. And I was like, look, real data. I have some ideas on things that might help your processing. At which point, obviously, we have like a happily ever after moment, right? Now our project is going to get solved from here. No, that's not really how it went down. There's this wonderful undergrad, Chris, and Chris had done a lot of the implementation to start training these models. And when I was looking at the model, he was like, so we've got like a 1,000,000-word vocabulary. And I went, OK, that's probably not going to work super well for this kind of model. Let's see if we can prune that vocabulary down from 1,000,000 to something a little bit smaller. And then we started looking more, and we were like, you're right, the topics are overfitting to company and product names. But there's this cool paper that's out about authorless topic models where it does some resampling of the data to try to reduce the effect of things that are very entity, like author specific, so that you can undersample if you know that some of your job postings are from Microsoft. You can get rid of the word Microsoft at least part of the time in those so that it doesn't mess the distribution up as much. We can split the job ads into separate paragraphs so that we can separate out the thing where they describe the skills for the thing where they talk about all of the different addresses that the company has, which is maybe a little less interesting to us. We can shrink the data set to a subset of jobs that actually mention AI or ML at all, and we can compare that to a subset of jobs that don't. We can, once we do that, we can go look at the LDA code and realize that the implementation of LDA inference that they're using is actually not a particularly good implementation. It says that it's implementing LDA, but it's actually doing an approximation of it that doesn't work super well. By the way, if any of you have tried to use topic models recently and have discovered that they haven't turned out well, I'm happy to talk to you about software and how some of it is slightly not advertising correctly what it's doing, but I won't name names right now, except maybe Jensen, but that's okay. And Chris is amazing, and Chris was like, I will continue to try to implement all of these different random things. And in general, when I've talked to people who are like not coming from a computer science background, Chris was not a computer science student. Chris was interested in political science and economics. He's currently working at a federal job. He does super cool stuff, but he was doing this sort of as like I'm curious if I can answer questions about this using computational techniques. But he, like almost everyone else I've seen in these fields, was not afraid to figure out programming stuff. He just didn't know that these were the questions to be focusing on. Like, why would this have mattered? And so we went through a bunch of this stuff, and after about 2 years, admittedly pandemic years, so there's a time dilation thing that happens there, we had an 100-topic model that we really liked, that we thought expressed different themes we were interested in. We could measure those themes over time. We could plot them. And then Chris graduated. And so we still have that model. And at some point, we'll hopefully write a paper about it. And I'll be very excited to talk to you all about it. But the paper is not out because Chris graduated. So this is like a sort of disappointing story, right? Wouldn't it have been nice if I had the They All Live Happily Ever After, come see my workshop talk at a UNLP? And unfortunately, this is not a unique story to this project. This actually happens all the time. So we had this moment where we're like, is it just us getting stuck on these sorts of things? Because I talked to some people, and it seemed like lots of people were getting stuck on the same thing. So summer 2020, I got 3 awesome undergrads, Alfredo, Tatsuki, and Theo. By the way, Alfredo is applying to grad schools this year and is super cool. So we should just throwing that out there. So that summer, we did 16 expert interviews. That is, we went around, we went on social media, we talked to people who talked to people. We recruited 16 people who were all folks who used topic models to understand some text collection, most of whom did not have prior computer science training before doing that. Some of them were professors in like the humanities or the social sciences. Some of them were people who were in industry but were like at a news agency or something like that. This group of people who are all united by this common process of actually taking a topic model and trying to learn something about a collection. They're not interested in evaluating models. They're not interested in the sort of like figuring out the state of the art. They're interested in what this text collection has within it. And our goal was to break down what their process was to do that, to ask them question by question sort of what the pieces were, the phases were, and how they made decisions within those phases. We used sort of something based off a framework called applied cognitive task analysis to be able to try to come up with a way to talk to them about the protocols they sort of came across. It included things like asking if you had to break your project down into no more than 6 phases, what would it be? And they would sort of try to do that. And then we'd say, OK, let's dig into those phases a little bit more. What were the actual specific choices you were using in those? And then what information did you use to make that particular choice once they identified one of those? So we'd sort of drill in on these things. Of course, as we did, usually they'd be like, actually, maybe that was 2 phases. Actually, that kind of blurs. And ultimately, we got back a lot of the same kinds of stories. And I don't want to force you to read this whole quote, but there's this giant phase that gets described of cleaning the data. And you find out in this phase, when you start cleaning the data, you think you've got something that works. You copied this other paper that was working on a similar data collection. It should work, right? And then you train the model, and something bad comes out. And you find out, once the model is trained, that there's still mistakes in the data set. And you go back and you try to find it. And then you make a new decision, and you try to do some other research for how you could actually fix that. And then you do it again. And you have to keep doing that. And that was months of my life, quote this researcher. This is referring to the first of several projects they did on this process. And that's what we found. This process right here, this data cleaning, which for most of us is like not the interesting part, right? This was months of their life. In some cases, a year plus of their life spent working on just getting the data set up. Actually acquiring the data set, a few weeks. Once they got the topic models to the state where they actually liked what was coming out of them, a few weeks. But that middle part was huge. We did identify, as we asked them about phases, basically everyone described the phases exactly the same way. And even when they didn't, we sort of talked to them more. And we discovered the phases are these, which is basically the recipe I showed you earlier, right? Obtain data, process data, build model, validate model, and perform model analysis. The main distinction right here is there's a between validating model and performing model analysis. When you're in a project where you're interested in a text collection and understanding what's going on inside that text collection, we have this breakdown of making sure that your model is something that's sufficiently modeling the data you're excited about, and then actually finding out what that tells you about jobs, right? And so these steps would get separated out in a way that maybe when we had our very first recipe don't get separated out. one thing that one of our interviewees actually told us was that we would often get frustrated because the NLP tutorial stopped here and didn't talk at all about what you then do with your topic model. They'd be like, congratulations, you now have a topic model. Have fun. And they would go make tons and tons of plots and sort of eventually find things that they thought were exciting, but they were like, this seems like more people would be doing that part, right? Shouldn't we be talking to each other? There were also two key elements that were important, though, in this recipe that I've left out. And that's that this was not a line. This had two different loops. One of these loops is data cleaning, and one of these loops is model tuning. And this might seem like an obvious thing, especially if you've worked on text data before. I'm pretty sure you've experienced these loops. We all have done some time in this loop. But it's weird because when we talk about a sort of classical like machine learning validation project, where we've already got an established data set, the idea that you'd be allowed to run the model and then go back and revisit the text is verboten, right? You're not supposed to do that. You're supposed to have a text data set that's ready to go, and you're not supposed to over-inspect it and then overfit your model to your data. But that's not the reason they're training these models. They're training it to find out something about the data set. And so they're doing this process of going back and going back and going back until it starts to reflect things that they know should be true about the data set from the expertise they have. Right? And these are not people who are messing around where they're like, oh, I found this, I thought it would be cool. They've studied jobs. Like they've studied the job market and read papers about what these trends are. They know what they should be expecting to see. Even if they think that there will be individual changes at a sort of more detailed level, they can tell if things are very, very wrong because they know enough about what that domain should look like to be like, these job postings should not all be talking about this. Something is missing. And when we were talking to people about this loop, one of the things that I sort of realized was that almost everyone was still using LDA. They'd occasionally mention other models, but they weren't using fancier models. I told you earlier, there's this whole like renaissance of probabilistic models where we were incorporating all of the parameters, and pretty much everyone here is either using LDA or in rare cases, structural topic models, which allow you to add a little bit of supervision if there's categories that you want sort of associated with your data. And what we found when we talked to people is they would say things like, oh yeah, well, I was working with some people in the project who really wanted a hierarchical model, which for the record not only totally exists, there's a bunch of hierarchical models that exist where you don't have to specify the number of topics. You can learn a hierarchy of different topics, and then you can decide sort of like where you make the cut points so that these two topics stay grouped together within the hierarchy rather than going into the two individual branches. So this thing that they described literally exists. But they felt like they didn't know enough about how these models actually behaved. They didn't really know that last step, like what do you then do with the analysis? Why is this happening? So they weren't exploring that further. They went with the model that was the one that people actually recognized. Enough people had written about using LDA for text analysis projects outside of CS that it was safe to use that. They wouldn't immediately be like shouted out of the room if they introduced that. But doing something more specialized, they neither had the expertise themselves, nor could they find the resources, nor could they find people in their community who would agree with that, even if they could build that information up, to be able to use a model that was fancier. So in spite of all of the model things that had happened, still use an LDA. And they were mentioning that this was sort of a perk too, right? The whole point about topic models is that they don't have to immediately know exactly what they're looking for. They can understand broad themes, what they expect to see, but they don't have to list all of the topics they expect to see in advance. They can evaluate based upon the information that's presented to them. And so as a result, even with structural topic models, they're just running these very straightforward models, and they're not getting that additional information. And so we did all of this surveying. We talked to these people. By the way, let me just check the time. How are we doing? We're good? All right, awesome. Sadly, there's a Zoom hover that's like directly on top of the time, so I'm just trusting you all to tell me if I've talked for too long. Okay. So we did a bunch of this talking to people, and we got all of these beautiful interviews, and we carefully transcribed them as best as we could. We're all computer scientists, and I'll say it, like I'm trained as a computer scientist. This was the first time I had done like IRB approval and doing interviews and things like that. And it's an adventure to do the first time. To be like, oh, this takes a lot more thought, and I'd fully appreciate it. It's slow work, but it was really exciting to draw all of these conclusions, but we didn't dig in too much. We did a first pass, and then the summer ended. And what we had figured out from our first pass was, wow, people are spending a lot of time doing this iterative process of trying to figure out their pre-processing. What if we help them do the pre-processing a little bit faster? What if we help them make those decisions with like a smoother user interface? So how do we do that? Well, we found this existing topic modeling tool, which is from my former advisor, David Mimno. He had made this web-based topic modeling engine just for a demo. Like, he was at a workshop and he realized that almost everything that ran topic models properly required the command line or some programming it. And he just wanted to show people kind of what it looked like to run one of these, that it was this random thing, that it required iteration for folks who hadn't previously worked on like iterated machine learning algorithms. So he had made like a really basic tool that showcased this in a way that we thought was more interpretable than the other tools we were researching. And we figured we probably didn't want to be the 20th people to introduce another topic modeling tool that no one used. So we started from that, and then we tried to add some features to make it easier to navigate some of these pre-processing decisions. And then we tried to run a user study on this new tool, and this was summer 2021. So we'd done some software development, we'd added some extra things to try to make it so you could like tag topics and add and remove them. And we recruited 15 people to go through and to use this particular tool. And we asked them sort of questions related to a movie review data set that we had. It was easy to get a hold of. By the way, Ingrid is also awesome, but both Ingrid and Jerry didn't want me to use pictures. So if this seems sort of random, it's their preference, not mine, that these are the pictures that are up. Ingrid is not an astronaut, but she could be. So they would start by like setting up this task of training topic models on this movie reviews data set, and we would give them questions like, can you find genres? Can you train topics and find something that looks like movie genres from this? We gave them a little tutorial on how to use the tool, and then sent them to do this for about half an hour, answer a few questions that are sort of like this, like, can you find out when these things show up together? Can you look at stuff over time? Because we had some nice time series plots in here. And then afterwards, we sort of had them walk through, like, what was your process for figuring things out? Where did you get stuck? What were the things you were spending time on? And we ran this study with 15 different people. Most of them were undergrads who hadn't previously worked with topic models. We found some people who weren't, but most of them were. Are we okay on sound? Sorry, I just heard a thing. Okay, cool. I wasn't sure if there was a question. And the end result of this new user study where we were going to improve things was basically finding out what we already knew. I've been looking back through the interviews more recently, and I have this beautiful quote from one of the interviewees who says, the practice of thinking about the process of topic modeling, about process, is not something that I can immediately dump on someone. Well, we had set up a user study that was not really asking the question that we wanted to answer. We were curious about how people who know a lot about a particular text collection, who are invested in that text, figure out these decisions about processing and how we can help them do that. And what we had instead done is found people who weren't at all invested in this particular random text collection we had picked out, who didn't know about topic models, tried to train them briefly and try to get them invested, and they were not invested. They were just mostly confused. So they would focus on the pre-processing things that they knew anything about from the tutorial, and they would just sort of iterate on that, since that was the only thing that they particularly engaged with. And so the interface, so first off, our user study wasn't really doing what we wanted it to do. And then when we dug in more, we realized that even if we had redesigned that user study and we'd found different participants and done this a different way, the interface wasn't actually addressing the problem that people were bringing up. And this is a classic case of what I think those of us who are coming from more of a computer science background, so when I say we, I don't know that that's necessarily all of you, but if you're coming from a more computer science background, I think that sometimes all of us are tempted into tech solutionism. We're like, these people from another field are trying to do something computational and they're having trouble with it. It's because they need more computational tools to help them. We need to give them better software, better user interfaces. They're just getting confused. And like, that wasn't the issue that they were having. I've talked to a lot of these folks, and they're perfectly happy to teach themselves, like I was saying with Chris, happy to teach themselves a new programming language, happy to use something in the command line. It's not ideal, but it's okay. It's doable. The issue wasn't that it wasn't possible to do these things. The issue was that they had different specific things they needed to do for every single one of their projects. That it changed depending on their data set, depending on their research question. And navigating those differences, that was the part that was hard. Giving them a general user interface that made those decisions easier wasn't helping them make those decisions. In fact, it was sometimes making those decisions for them in a way that they didn't know they didn't want. And that was actually the opposite of helping. So in this case, this is somebody who was working on a data set associated with Twitter. They mentioned, like, A natural thing I didn't even talk about in my list of preprocessing is getting rid of punctuation. If you're training a topic model, you're probably not interested in the counts of punctuation, except occasionally when you are. In which case, you probably don't want to throw that information away, right? But if you're just following an existing guide, or you're following the default parameters in the way a lot of these NLP resources work, you can get to a place where you don't even know that's a question you should ask. Like, is this removing all of my preprocessing? Sometimes one of the tools that I use regularly, automatically removes anything that's fewer than 2 characters. Which, if you're not working on an English data set, removing words that are fewer than 2 characters is a really bad idea. And yet, it was built with this default in there, with the idea that that would help people do things more out of the box. So these defaults were causing problems. And the fact that oftentimes there were preprocessing decisions described in sample papers that were doing something similar, where they would be like, we did this, and then this, and then this. And there wasn't a rationale. Meant that people were losing out on how to actually make these decisions for an entirely new data set, for a new question. And that was really the friction point. It wasn't whether or not you could do this process. It was knowing which of these pieces were worthwhile and why they were being done in the first place. So what do we learn? Just backing out a little bit. We're still working on sort of pulling out all of the information. I've got like 150 pages worth of people just talking about topic models and how they work on it, and it's delightful to read through. But there's some key ideas that we can first learn from all of this. First off, the questions that people ask about text and corpora are unique. And going back maybe a little bit in a silly way to my cake analogy, we can talk about whether or not you know how to make a cake broadly, right? What the broad picture of that is. Yeah, you're going to mix together some ingredients, which will probably include something like flour, unless it's a flourless chocolate cake. And then you're going to bake the cake, and then it will look like a cake, right? And we might even have concepts of what does cake look like. But there are so many variants of cake. There are so many different individual things that could happen. And depending on those things, slightly different decisions have to be made that can have vastly different outcomes. If you're making a cake with lots of egg in it and you don't want to accidentally make scrambled eggs, it's a good idea to use a recipe that's aware of you using lots of egg in your cake. I don't know if anyone's accidentally made scrambled egg cakes. Maybe that's just me. It's a rough time. Yeah, okay, thank you, Emma, for backing me up. What is it, the Genoese cakes? It's a really bad. I made a lot of scrambled eggs by mistake. Next thing, simple models are okay, and in some cases necessary, right? And actually, people are able to find things that are interesting and meaningful using a model that isn't encoding all of the assumptions of what are the specific structural things they need, just to do discovery. Lots and lots of papers come out that are still using LDA, this 20-year-old model, every single day. Usually, I think there's about 3,000 citations of LDA a year. They're roughly stabilized around there. It's a 20-year-old model, but it's effective at doing this very simple thing that then allows you to do analysis after the fact. That's okay, it's working. And it's still working for a large community of people. We're not necessarily supporting them to help actually navigate how to make those work the best possible at this point, though. And I think the last thing that I would mention in this sort of particular learning thing is, as we look at their process, a key thing for us to realize is that outside of the community where we're actually evaluating these models, for those who are focused more on the data set than whether they're proving that this model is the new state of the art, retraining the model and then making pre-processing decisions a different way and then retraining the model, that's part of the process. And in fact, training the model itself is key in that process. If you train a topic model on text that says that it's monolingual and it's not, you get a topic for the language that shouldn't be in there, right? I did this before where I had a Spanish language corpus that 100% had English news in it. And I couldn't tell. I read through skimmed through 100 articles. They were all in Spanish. And then I trained the topic model and I got an English topic. And I was like, I don't think that this is 100% a Spanish language corpus. So this tool of actually having the model in the loop of how we think about processing can be really valuable, as long as we're careful about formulating which questions we're asking and answering with that. And we should keep in mind that that's a process that a lot of people are inadvertently engaging in and rediscovering, and think about what it means for our models to be part of that process. How do we help people diagnose whether their models have some issue with the processing that needs to be managed? And then what can we do as a result of finding this stuff out? Well, first off, I would be a strong advocate for talking to experts when you're working with data. Not just experts in data broadly construed, but experts in specific text collections, because you might find out insights about what they care about or how they use that data or how they think about what structure is meaningful in that data that you wouldn't expect. Without that information, without the information about how they actually engage, it's really easy for us to make assumptions of I know what will solve the problem. I'll give you an interface that simplifies this stuff. without including the other pieces of their process. So talking to experts is key. It also gives you intuitions of what actually is easy and hard to do. I think once we do something long enough and we're in a community of people where we all have written the same Python program that writes the same neural net, like it's easy for us to get comfortable with what's easy and hard to do in our local community and then forget about what it looks like in a broader academic space. It's also fun. I get to learn things about topics that I never studied. It's a delight. Document your processes. There is an incentive in writing papers that have an 8-page limit to not spend a lot of time talking in detail about text processing because it's not the interesting part. Unfortunately, it makes it so the processes aren't replicable, and so people can't learn from them when they're trying to decide their processing. You probably can't fit it in your actual paper, but I would love to see more appendices that really talk, if you're using a new text collection, about the details of the processing. And not just, we stemmed, or we lemmatized, or we removed punctuation, but why that was a good decision. Because I think that you all actually have the ability to justify those decisions. And if we can share those justifications in writing, then other people can use them. But right now, we don't have that. We have incentives against including that in our papers. And I don't think that's good for us as a community. And the last thing is learn from students. I think one of the greatest gifts in this process of working with students like Chris, like Theo, like Ingrid, who's not an astronaut but could be, is that I have gotten to watch them learn how topic modeling works and what's confusing about it and what's delightful about it. Like the magical moment that they train a topic model, learning that explanation of what topic models are and being like, that shouldn't work. And they train it and it works. And they're like, how did that find anything useful? That's wild. And it's cool to participate in that process and to rediscover what's interesting, what's challenging. I think it's helped me form research questions that I wouldn't have previously thought about when I was surrounded by people who were already evaluating these things. And so I'm very pro, like, working with undergrads at least every once in a while, like see how they think about that, how they form their knowledge around these topics, because it can help you get excited about things you didn't know were inside the topics you're working on. So with that, I just wanted to include, I work with lots of other people, but I wanted to especially include a list of undergrads who are involved in various pieces of the project that weren't in the main components I talked about today. I work with a lot of cool undergrads, sadly not as long as I want to, because I usually only get them for a summer or a semester. But these are some of the wonderful people. This is a cookie version of the statistical model of LDA in case anybody really needed a graphical model in their life. I don't like putting just the figure up, but if it's in cookies, it's okay, right? And at this point, I'd be happy to take any questions. So thank you.
I have a question.
Yeah.
So you talked about a lot about the pitfalls and the problems of preprocessing. Seems to be being heard. I think most of us know that here.
Yeah.
How do you feel? One of the benefits supposedly that deeper models give you is that like you don't have. I see preprocessing as like in some form of inductive bias that you put in your overall model, including preprocessing. And supposedly one of the benefits of deep learning is that you don't have to put as much inductive bias. It learns by itself. How do you think moving to deeper models, despite all the pitfalls, I know they have their problems, is going to help as well with reducing the burden in preprocessing?
It's a really great question. So the question is, how could deep learning models potentially help with this?
Yeah, for example, I see tokenized free models helping a lot with choosing the weird tokenization decisions that we make.
Yes, so one thing I will say, so for these task-oriented problems that I think a lot of us focus on, I think that deep learning has been exceptionally good at being able to help remove some of these things because we can sort of like, it learns representations within the text that can focus it. For this text exploration space, it gets a lot trickier because you don't just need something that performs the best at that task. You need to be able to explain what themes are showing up and why and how those are grounded in reality. And so if the decisions are being made in parameters that are buried within a model, that actually doesn't write in an economics paper particularly well.
There's interpretability issue here.
There's a big interpretability issue that comes with neural nets. Now, I don't think that that means that they couldn't be part of the solution. There are actually neural topic models as part of what I was talking about before. One of the reasons I think that they haven't been adopted as much, well, there's a few different reasons. One of them is this interpretability thing. They actually, at the end, can produce something that looks kind of like the models we had before, but the internal weights, the things that are helping like figure out preprocessing, aren't something that you can easily report on. So I think that's one issue. Other issues are, honestly, for a lot of like digital humanists and social scientists, the computing resources that they have available to them are a MacBook. And so you need to ask, like, what model can you run on 40,000 documents in a MacBook? And there are some restrictions on what you can do with neural modeling that way, right? Like, a lot of the things that are making the most outstanding results today, the things that completely I could not have imagined when I first started grad school in NLP that are happening now. It just blows me away. And they require way more computational resources than that.
We cannot run readers and all that.
Yeah, no, I mean, unless you're like one of 5 companies, I'm pretty sure you can't run almost any of these things. But because of that, there's a lot of restrictions in terms of what models are possible. You can still get some neural models to run, but they're probably not going to get enough data just because of the types of data sets that these folks are working on, and they're not going to get enough compute power to be able to do something that's highly sophisticated within that space. So it's probably not going to get all of the wins that we see on the nicest version of the model on the biggest computational resources. And then the last thing I think is that there's a specific thing regarding neural topic models where because they're primarily trained to optimize these metrics, they've had some weird, quirky things happen. So the literature around neural topic models, a lot of that has focused on coherence metrics. Like the message about likelihood being the only thing was well received. Like, oh, we should have topics that actually are thematically meaningful. We're going to approximate that based upon probabilities of these words showing up together in a close context in a reference corpus. And the topics that have then come out as a result of that, and a lot of the papers that have used neural topic models are ones that they've shown like improve over LDA on automatically computed coherence. But then there's this paper by Alexander Hoyle that shows actually when we look at automated coherence versus humans' actual judgments of coherence, these models are too specific and they're not necessarily getting good coverage. Either like it's usually not a diversity issue, usually the topics are distinctive, but they're not actually necessarily getting at the full like surrounding group of themes, because if there are highly easily to detect coherent themes, those are the things that'll go up to the top because we're trying to maximize coherence. And some of the slightly more general or vaguer things, like if you're studying a text collection of speeches, you'll get topics that are rhetorical. Like you'll get things that are about like, oh, they're talking about the government, they're talking about policy. They're telling a story, and they're using words that you use when you talk about a person in a story. And those topics aren't the sort of things that the neural topic models like to converge to. And so I think that's the other piece for why that hasn't caught on yet. I believe that part will get fixed.
Yeah, I think this is, I mean, I don't know enough about this topic to
Yeah.
make a for this, but I think this is kind of fixable. So I'll summarize the last question. Do you think LDA will still be cited 3,000 times a year in 10 years?
Do I think it'll still be cited 3,000 times a year in 10 years? I mean, I think some things eventually are so well cited that they can't stop being cited.
Yeah, but reframe the question. Will people start moving to neural topics?
Do I think people will start moving to neural topics? This community, I actually think it's probably going to be more than 10 years before they'd move to that. I actually don't know that neural topics on their own are going to solve that problem, because ultimately, in their best form, they're still not fixing the issue. But we can chat more later. Let's move on to something else. Yeah.
So related to the last thing you said, it just got me thinking, because I know that what people expect to see out of the topic models kind of depends on the research questions to what extent. But there are somewhat not automatic, but based on human judgment ways of kind of creating topics like thematic analysis.
Yeah.
So I wonder if there's any work looking at commonalities of what like people consider topics, because it's kind of like in this process people kind of annotate it, but they might like merge topics or split topics every time.
Right.
So I was thinking if there's any work looking at what kind of topics people tend to like find useful and things, and if that could help guide the topic models, because ultimately if you're working with like social scientists, like you want to have like topics that are like, useful to them, or approximating what they would come up with if they annotated by themselves.
Right. Yeah. So the question is like, are there topics, like, is there work on topic modeling that helps include sort of like people's direct judgments about what's useful or not, and helps? So I don't think that there's a lot that summarizes across everybody, because like we said before, there's not a full summary, but there is absolutely work both on how to include humans in the loop for that, as well as thinking about like what are the structures we can have in order to be able to include supervision. So there's the type of supervision where you're like, I have other labels. Like I have information I know about this data set. For instance, I know these documents are about things I care about more. I'm working on a different thing with The Economist that's related to filings from companies after disruptive events, like COVID, but also like demonetization in India. And what are the consequences of that? And so we're interested in the reports, but we're interested in particular sections of the reports. And we can go through and label and be like, we know these are the sections where they're going to talk about this. And we could use that without throwing away the other data. And there are models like structured topic models, like seeded topic models and seeded LVA, and some more recent versions of that that are variants that use matrix decomposition methods that are more recent, that use neural methods to do that same kind of supervision. The reason that I think those get picked up less is sometimes because there's fundamentally a desire to, without doing hypothesis testing, test a hypothesis. They're like, I think that this is the thing that's interesting. If I give a model no information about what I think is interesting, does it agree with me? And so I think they often go to a very naive model actually because they're interested in seeing if that's what happens or not. Occasionally there's like a serendipitous moment where something completely different arises, but they're like, oh wait, that's really exciting, and they write a wholly different paper. A lot of the time they're sort of, oh, that sort of agrees with me and sort of disagrees with me in other ways. Let's explore that more. The other piece though is that there's humans in the loop. And there's both, there was originally some work that was on interactive topic models from out of Jordan Boyd-Graeber's group, which used sort of the ability for people to, as a topic model was trained, you'd get a certain number of topics out, and you could say, hey, these two should be merged into one, this one should be split, and then train it a little longer, and then make those decisions. And there's an equivalent version of that with anchor words topic models, where you get to specify word anchors that you're using for your topics, and you can merge anchors and split them apart so that if there are particular topics you're interested in finding, you can ground them that way. And it allows you to have interaction. I think that those might catch on more. I think, again, for the same reasons we were talking about before, because people sort of have this, not hypothesis testing, but hypothesis testing-like desire to see what the model finds, that those don't always get used. But yeah, does that answer your question?
Yeah, thanks.
I realize we may be short on time. Are we okay?
One more, and then we'll move to snacks.
Awesome.
Does anybody else have one? It's gonna be really good, Dan.
So yeah, thanks. This was super cool. And I was wondering if you could say a little bit more about. You talked about like teaching research and informing each other, and if you could say a bit about kind of like your thoughts on maybe how that works in a classroom setting too, because this is like something I grapple with. Like, you know, how much do we kind of teach stuff that's past the test of time versus the fast moving stuff that's kind of getting introduced.
Yeah, I was actually having a great discussion with the folks who were at lunch today about exactly like how when you're teaching NLP classes, especially, I teach a natural language processing class at an entirely undergraduate institution. So I'm going to be the last class they take there on that if they're going to take any. What do I include? My experience has been that if I want to talk about the state of the art neural methods, I have to make at least half, if not all of my class neural approaches. Like I lose a bunch of the classical NLP stuff because otherwise I don't have enough time to introduce it. So my experience, first off, on that particular piece has been I have tended towards pointing people towards other resources if they're excited about it, talking about current papers, but really focusing on things about evaluation and why, in spite of all of the different unique tasks that we work on as NLP practitioners or language technologies practitioners, why we are all united by the common theme of evaluation being exceptionally hard. Like that language evaluation somehow just adds additional challenges to our lives in ways that, of course, linguists have known for centuries, but like that complexity is something that we grapple with, and we often run into the same problems over and over. So I think in my class, I admittedly don't always get as much into these specific pieces. I only sometimes talk to my NLP class about topic models even, but we spend a lot of time talking about like how does data processing actually affect our models, and is it worth making decisions about that? We'll look at neural or like papers that are using deep learning approaches, and we'll talk about which things they're talking about and which things they aren't talking about in the paper and what that might mean. So I think in like terms of the classroom stuff, this is something I have not resolved. I've talked to a bunch of other undergrad institution NLP professors, and none of us quite know what to do with the fact that now, like with deep learning stuff, the class does not fit in a semester for an undergrad. But I think the other piece of your question you were asking about was like, how does this inform my research, like the teaching? Which I know is a theme that was already visited recently, right? in this same talk series. And I think that one of the biggest things for me in informing my teaching is like listening to the questions that students ask and thinking about whether I actually know the answer to that question or whether I think I know the answer because I recognize the keywords. We all have the power to answer the question we want to have heard, right? In fact, that was a strategy I was taught when I was going on the job market. It's like, don't answer the question that they asked you that's really hard. Answer the question that you want to answer. And then pretend you didn't hear them right. But, I mean, don't do that, but you know, if you need to, do that. But my sense when I was first starting to teach NLP to undergrads was that sometimes they would ask me questions about processing, about these problems, about what was easy and what was hard and what people had already done and what they hadn't. And I would naturally answer based upon sort of the keyword associations that I already had with those terms. And I didn't spend enough time initially really grasping what they were asking and getting them to talk about their examples, or the fact that they actually had a project idea in mind and they were asking because they had this thing, but they were kind of nervous to even ask if that was a viable NLP thing to do. I think the more I've been opened up to that I've been like, actually, my guess is when you're asking that, you're not thinking about the same thing I'm thinking about. Can you tell me more? The more I've discovered areas that, first off, I don't know as much about as the things that I naturally want to answer. So I end up reading more papers about topics that I didn't previously think about. And also, the more I've discovered that there are things that are just unanswered that I hadn't worried about because they aren't in the set of topics I regularly visit. So I find that that's been really cool. Sometimes I also get asked questions where I do 100%. I'm like, no, I know what the answer to that. There's the thing with the count. It's fine. But I think those are the pieces, like the getting to see the curiosity and also just getting to live vicariously through people finding out that this stuff works for the first time is pretty fun. So that keeps me energized in the days when I have to do really boring experiments.
Cool. Thank you once more.